On Thursday, students are going to need to look back at the data that they collected yesterday, Wednesday, and try to make sense of what is going on. So on page 34, students are going to be thinking about how the light and the temperature were varied. And do notice that when we look at the digital notebook for students, that I was intentional with placing these images to help support student learning. So we have the sun icon for anything with light and the temperature icon for anything, or the thermometer icon for anything with the temperature. And that is in each of the pages here, again, to support students, particularly students that might have difficulty tracking between multiple pieces of information and or are some of our multilingual scholars. So what they're going to need to do is answer the question, but they should be including specific data. So for example, the first question is, do all the surfaces receive a similar amount of incoming light? So they would answer yes or no, and then say, for example, and give one or two different examples. They will do that for each of these. Once that is done, we'll bring our students back together and think about energy as it relates to the sun and light, and then how that might then be related to what's going on with the temperature. So what's the connection between the light energy and the heat energy? So students are going to be completing page 35 and then coming back and talking about these ideas as a whole class. So thinking about if the temperatures vary at different locations, how could we represent that in a model? So for the work time, you will be working on teaching students how to make a model of what is going on when air has different temperatures at different elevations. So guiding questions are what happens when the light reaches the ground, what happens to the temperature of the ground, and then what happens to the air in contact with the ground. So what that means is for our model, we're going to need to be including light. We need to include zoom ins of the air, both right at the ground and 4 feet above the ground. And then we're going to be wanting to indicate which molecules are moving faster and why that might be. And then we're going to need to include how the energy is transferring from the light to the surface and then to the air. So those are all components that are going to need to be in that model. And I will be making a model and another instructional video to support you in supporting students. And then we're going to just close with asking students to think about how does a model allow us to make unseen processes visible? And then how can we use models to make predictions? And then overall, how do models support their learning in science? So again, anytime we can get students to be thinking about what do the tools do for them, it will increase their buy-in, increase their engagement, and deepen their access to the content. Friday, the slides are not yet ready, but Friday we're just going to be doing another summary chart that's going to be very similar to the one that we did on Monday, where students are thinking about what are the activities that we did to learn, what were the ideas that we learned, and then how do those ideas help us understand what causes hailstorms. And then finally, I would like students to finish the week with a reflection on not only what they learned and where they might be having some questions, but again, what were the tools that supported them in their learning, and what academic goals do they have for themselves for next week. When you are thinking about what to put in that summary chart, again, that's when it's helpful to come back to this weather unit overview. And for each of the lessons, there is a highlighted in yellow here text that goes over what did we do and what did we figure out. As well, here's a possible model that we might use for the model in day 2 of the lesson.